sort of operations we can apply to various arithmetic operations, etc. We're also looking at and some more advanced mathematical is available. Part of this lesson, we discuss Boolean do conditional processing in code like else, and also we're looking at a way to control flow with a switch statements. Another topic in the lesson is describing the program called JShell, which is a very useful tool to experiment with code without actually having to write full-blown Java programs. The reason why JShell is mentioned here is because, in fact, at the end of the lesson, we were encouraged to do exercises in that tool using JShell.
Qué lindo.
Let's start with
Qué lindo dibujo está haciendo. Claro, no se acuerda.
from smallest to biggest by short numbers. 2 times represent float numbers. The smaller one is float, 32-bit number, and the bigger one is doubles. And the chart value represented in character. And finally, the Boolean, which can represent true or false values. Now, what this page shows us is precision for each type, so ranges of values, and please note that all numeric values here are signed, i.e. they could be both positive or negative. So for example, for the byte, the range of values is from -128 to -127. We also could see here what's a default value for a variable of a certain type. And as you notice, the numbers are all defaulted to 0. Actually, the char is defaulted to Unicode character 0, which corresponds to a particular character on a keyboard. That's character code. Now, the other thing that you can see from this page is how could you express values for corresponding numbers? So for whole numbers, for example, you can use representation, octal, 8 base numbers, decimal base numbers, and 16 base numbers hex representation. Also note that to distinguish the value of int from long, on the end of the long number you add letter L. You can use lower L, uppercase L, that's up to you, but obviously lowercase L is probably less readable because it could be so uppercase floating point. You could use exponential powers of
Pero te lo comes allá más sala aquí, ¿no? ¿Viste?
and a very similar trick to distinguish float from double. At the end of the float value, you add F, indicating that that's float rather than double. Again, you can use uppercase F, but probably uppercase for readability reasons. With the char, the values could be expressed as just a character, single quotes, which is very important, has to be in single quotes, or it could be character codes, could be Unicode codes, /U means a Unicode code. If there's no /U, if it's just slash number, then it's basically you could also use escape sequences such as /T for tab, /B for backspace, and for new line, etc. Oh, and you could obviously notice that quote itself could be escaped with a slash symbol. Actually, the slash could be escaped with a slash symbol, just with a slash. Yeah. And Boolean values are expressed as 2 reserved words, true and false. So you cannot really assign like a string or number to Boolean. It actually has to be one of these 2 reserved words. So, now, what do we do with these primitive numbers? Well, we perform various operations. But before we do that, let's just make sure we understand how we declare a variable of a particular So the syntax looks like this. Type followed by variable name, optionally equals value. You don't have to initialize the variable immediately. That might be a good idea, but technically you don't have to do it. You could initialize the variable later in the code so long as you initialize it before you actually try to use it. If not, the compiler will probably object to that. And then there's usually statements terminated by semicolon, which is expected for any Java statement. Variable can be expressed, variable value can be expressed in all these different ways. You see the examples here. A is expressed as a binary number, B is expressed as octal, C is decimal, D is hex, whatever. Also, don't forget that if you have like a float to indicate f at the end, and this one is an exponential notation, because you can, I guess. With the double, you don't need to put f, obviously. Now, here's another interesting thing. Variable can be assigned a value of a previously initialized variable. In this particular case, long variable g equals 5 and h equals c, and c is some other variable you previously have initialized. So, one variable can be used to initialize another. Notice that it's perfectly plausible to initialize values of bigger types with values that represent smaller types. So for example, in this particular case, h happens to be long and c happens to be byte, and byte is obviously smaller than long. It's 8-bit versus 64-bit, right? So you can take this smaller value and just assign it to a larger variable, and it's automatically promoted to the larger type. So it will be accepted. And it works across different types. So for example, in this case, g happens to be a long value and assign it to float. Floating point number is considered to be larger than the whole number. It's kind of the idea. So you can take any basic, take any whole number and assign it to a floating point variable. Now, the next example here initializes a char. It's just double quotes. Single quotes. Oh gosh. Yeah, that's very important. Char is initialized using a single quoted character. And then you could use Unicode codes or ASCII codes. Also notice that multiple initializations can appear on the same line, comma separated, so long as they are the same type. So G and H are both longs, K and L are both chars, and yeah, you could initialize several variables and declare several variables in one go using this comma separated. And the last example basically just shows us that a variable S is declared and initialized a little bit later. So long as you do it before you try to use variable S, you're perfectly fine. Now, this is how you declare and initialize primitives. Next page shows you how not to do it. Let's take a quick look at typical errors, problems that you may encounter when you initialize. So, first of all, do not use a non-initialized primitive like this. It's not initialized, and shall I assign it to be, and the compiler will object to that. Also, on the next example, you can see that clearly the value is bigger outside the range of byte time. Yeah, the value is from -128 plus 127, and 128 is clearly outside of the range. So the value doesn't fit the capacity of time. On the next line, 42L, you see L indicates that value is long rather than mean. 42 per se is within boundaries of mean, you're perfectly fine, but you're explicitly indicating that you want a long number rather than a mean number. So the value on the right-hand side of the equal sign, right-hand side of the expression, can be larger than the variable you're trying to, capacitive variable you're trying to assign it to on the left-hand side. Likewise, on the next line of code, what's wrong with that? Well, there's missing letter F to indicate that it's 1.2. By default, 1.2 letter F, that's considered to be double binary float, so it cannot be assigned to a float. Double quotes around the char, but it should be single. two letters in char, but that's char is a character code, a single character. And you, of course, you cannot use true or false strings or chars or whatever, or even as numbers, you know, 0, 1, as Boolean values. They actually have to be keywords, words true and false. Actually, on that note, you know that Java is case sensitive, so all Java keywords and reserved words are lowercase, including the true and false. So spell it in a different case, and you know the compiler will say, "Well, I don't know what that is," right? So all of these examples will cause Java code not to Okay, now let's take a look at the operators applied to groups. So what is important about this page is that it shows us generally what the operators are. Actually, some of them apply to not just derivatives, but to objects as well, but we'll talk about it later. But what most important about this page is the precedence, the order in which operators are applied to use that same expression. So obviously you can use multiple different operators together. Of course, the order can change with round brackets, with parentheses, order, but that's the default. Now, what we're going to do is just look at these operators, sort of, you know, one by one, and try to figure out what they do, how they work. And we'll start with arithmetic operators. Arithmetic, and on that note, well, assignment as well, actually. Assignment is a simple equal sign, so one assigned to A. Yeah? This is just that. But assignment can also handle expressions such as arithmetic expressions. So on the right-hand side of assignment, you can have some expression, you evaluate that, and the result is assigned to whatever is on the left-hand side of the expression. The expressions themselves may represent various arithmetic operations: addition, subtraction, multiplication, division, and the percent sign stands for modulus, or remainder of division. You can see how the math works here. Now, you may combine the arithmetic operator and the assignment together in sort of one compound assignment statement. In a sense, you could write A equals A plus B, but actually A plus equals B does exactly the same thing. There is no difference at all whatsoever. So if you want to apply arithmetic operator to a variable and then assign the results basically to the same variable, well, just do this, you know, plus equals, minus equals, divide equals. So you can just do it right. There is now, the order, as I've already mentioned, if you use multiple operators in the same equation, then the order is so whatever is inside the brackets, whatever is inside parentheses, is evaluated first, and they can override it. Now, the plus, plus, and minus, minus. These are really interesting operators. They increment the number or decrement the number by 1. Right? So you have a variable here, integer a, equals 1, and you do a plus plus, and it becomes 2. You do plus plus a, it becomes 3. So, what's the difference then? Why do you have this prefix and constant quotations? It's similarly doing the same thing, you know, incrementing or decrementing. But you see, the difference would be obvious if you start combining the plus plus and minus minus with their sign in the same line of code. And then the difference becomes obvious, because you see what happens here is the order in which you do things matters. If you say b equals a plus plus, then you will first take the value, assign it to b, and only then increment the if you do it the other way around, if you say b equals plus plus a, basically, right? Then you first increment a, right? Minus minus decrement, whatever, yeah? And then assign the results to it. So it's the order in which it is done. If you're not doing that assignment, if you just do plus plus and minus minus on its own, well, apparently you can recursively modifying the same variable, right? So a variable gets incremented or decremented, right? So no assignment is really required as such, just to perform incremental decrement. Assignment is kind of a separate action applied to some other variable, and then the order in which you do it matters. Yeah, do assign first and then increment. That's the decrement. That's the postfix notation. Or do increment or decrement first and then assign. That's the prefix notation. Again, mostly cryptography APIs. Left and right shift on, well, imagine a binary number. I'm just giving two examples, which is, negative and positive, so you can kind of see how it behaves in case, right? And then you just shifting it to, well, first we shift it to two digits, two positions to the left. So the whole number kind of literally pushed, yeah, to the left, and the right hand side we're filling in the zeros. Okay, so you could push the number to the right. Yeah? So that's the right shift. But there's also a variant of the right shift. A variant of the right shift which fills in the outwards left hand side part with zeros rather than returns whatever sign there was. So with a negative number is all ones, right? So basically, in negative numbers, the first position is always one. You can tell, kind of clear. So if that's the case, and you do the normal right shift, then the value will be filled in with ones on the left hand side. But if you do this assigned right shift, the value will be filled with zeros. So it's going to behave the same. Okay, again, this is mostly network programming, cryptographics, this is probably not that much used in regular database or business logic. Nevertheless, nice to know just in case of contracts operators. Syntax a little bit by not very. Wow. If you write it now, let's get from these slightly esoteric subjects to more sort of practical angle of Java, and this is relational equality and conditional operators. So we're comparing things, equals, double equal sign, don't confuse it with a sign, single equal sign. Not equals, that's an exclamation mark, and generally exclamation mark means not, so it negates true and false. Greater, less than operators, comparing things, and also you've got and or an exclusive, so that allows you to combine conditions. So for example, A greater than B and so for and, both parts must be true in order for the results to be true. For or, one part must be true. Maybe false.
¿Qué pasó, bebé? Bebé.
Either part has to be true and the other part has to be false.
¿Por qué entonces?
Now, don't have to put round brackets around booleans, but it may make it a little bit more readable. Now there's also, instead of double ampersand and double vertical line, there's also single ampersand and single vertical line. And then has full variation versus the double ampersand and double vertical line, which is shortest. Which actually explains the difference. The difference is this. If you look at second part can evaluate true or false. Don't know, and it depends. The overall result of the expression will really depend on what the second part would say in this case, right? Just remember, having condition both parts need to be true for the overall result. So we have to evaluate both parts to tell the next case, the first part needs to be false. So you evaluate the first part. Outcome of this expression. Sure, because it doesn't matter what the second part is. If it's true or if it's false, if the first part is false, then use it. So with the double ampersand, the second part will not be Java will simply not. If the first part is and with an or, yeah, if you use a double vertical line, if the first part is true, there's no point evaluating the second part, right? Because you can predict the overall result of the expression. With exclusive or such prediction is not possible. You actually have to evaluate both parts because they specific. But with the normal and or, you could switch off, turn off that short circuit evaluation mechanic and force Java to always evaluate both sides of the expression by using single ampersand or single vertical. So that will cause both ampersand there's a kind of switches off optimization, right? You seem to be doing extra work. You seem to be evaluating parts of the expression where you don't really need to because and generally yes, you probably don't want to do but there is a strange case. The second part of expression isn't just doing the bridge. What is the part of expression? Actually performs actions as well. So in this particular case, as you can see in this example, there's a case, right? So there's an action. It's not just the logical check. And then if you use the double ampersand, double vertical, the execution of the second part of the expression becomes a hinged condition. While what would be the first one? So that means that in some cases implemented and in other cases it won't be. And it would be hinged on what the first part of that expression is. And you can switch that off, force B to always be evaluated by using a single vertical line or a single ampersand, basically full version of evaluation rather than short circuit. Is that a good idea? Probably not. I would consider doing that B++, that action outside of the condition that you're using some logical checks. So do the B++ before or after that, but not inside it, inside the condition. Because then you'll have to think about what type of short circuit, not short circuit, whatever evaluation you're using, and the code becomes kind of less transparent to read and can be difficult to understand. So general idea is probably that you don't want to mix the Boolean logic and actions inside the same expression precisely because of that ambiguity potential and dependency to the type of evaluation you're using, full or short circuit. And generally then, if you avoid doing actions and Boolean checks inside the same expression, then you can always use short circuit evaluation. Now, where these Boolean expressions are used, well, where you like, but you can use them to control the flow problem with an if-else construct. The syntax is pretty straightforward. If followed by the Boolean expression, which can include true or false, and if you use true, then a block of code after the if will be executed. And if the Boolean expression
Mercado Pago está diciendo que opine sobre ti.
The else block is actually optional. If there's one single statement inside or inside else, just one
¿Cómo califica año perdido?
Beware of that because you can sort of, forget that that's supposed to really be a block of code here. Yeah, so obviously if you put more than one statement inside the else, the compiler will object if you don't have curly brackets around. Say but with else it could actually be kind of tricky because you forgot to put the curly brackets. You put one statement inside else and everything else is inside.
Bebé, ¿qué vamos a hacer de cena? ¿No se de cocinar? Yo tengo más celito
So the
de mi
next line of code is
corazón.
actually executed on
¿Ese no qué? ¿Ese no qué, mami?
¡Ay, Dios!
Lo siento, mami.
¿Qué vamos a cenar, hijita? ¿Qué cenamos? Baby?
Now, you may embed an if
Uno,
else
dos,
inside
mami.
or inside an else. Sure, as much as you like. So in this particular case, there's some
Hacemos unas hot cakes.
single statement inside this if.
¿Qué?
Hot cakes.
¿Un pastel?
Then if you add an
Hot
else
cake.
inside
¿Qué?
Hot cake
then there's
es
this else block, and inside this
pancakes.
else, I just embed another
¿Pancakes?
else.
Mhm.
Yeah. And you can do
Pero
as much as you like.
pastel, yo quiero, mami.
Ifs, for instance. However, if you skip these curly brackets, if you decided to omit them, then you can get into
¿Quieres ayudarme a hacer unos pancakes?
trouble reading that code. It may be difficult to read because you see alignments and nomenclatures don't matter. So you will misread it. I've seen people kind of read it.
Tengo mucho frío, Maita. Tengo mucho frío.
No, there isn't. It's just that they can add it into else, right? Inside the block of code. essentially. So that else
Mamita,
belongs to
¿Tú
that
tienes mucho
is
frío?
inner.
Sí.
This else is
Entonces,
nothing to do.
¿quieres tú una manta?
Essentially,
arrópate.
this block of code is doing
Arrópate,
exact
que hay
same
mucho
thing as
viento.
this, for example. There's no
Mamita, arrópate.
Ya,
here,
ya,
the
ya.
curly brackets are there. And then the alignments are a little bit off. And
Bebé, ¿me vas a ayudar a cocinar?
Pero yo quiero dormir.
consider
Yo quería dormir.
always putting whatever is best for you. Whatever is the best way of conveying the idea of what the problem is. You need curly brackets.
¿Quieres dormir?
That's as far as I want to get. Yeah. Okay. Right. So that's if else. Now, in addition to these flow control constructs, we also have another interesting sort of twist on these if else statements. Yeah. That's a ternary operator. The ternary operator is used specifically for just one reason: conditional assignment of a value. So if you've got a variable here, a variable C,
¿Ya despertaste?
and I want to assign that to the
Quiero
basic
dormir.
condition, then what I could do is put the condition around that here. Yeah? Then question mark, value that after the question mark, value that you want to assign to variable C when that expression means true. Then colon, and then a value you want to assign to variable C when that expression means false. So literally that, yeah? Expression, value, true, value, false, yeah? You could have written that as an if else block, sure. Absolutely. Yeah. If condition and assign C to something if it's true and C to something else if it's false. Fine. But then whoever reads that code thinks there's more going on. So, you have an if else statement. They have a block of code. So what are you doing? Oh, actually, I'm just assigning one variable. You might as well do it as the ternary operator. Again, the point is you need to try to clearly convey the purpose of what you're trying to do. You've got a block of code executing logic. If you just want to assign a variable,
¿Cuántas pancakes te vas a comer?
otherwise they can.
No quiero pancake.
Can you embed one ternary inside another? Well, technically, yes, you can. But again, at some stage, it just
Bueno,
becomes
¿qué vas a
not very
cenar?
needed. Yeah? So putting condition and question mark value when true, and column value when false. Another question mark.
No sé.
So it's like a ban and leaf house and two house kind of thing, right? Can you do it? Technically, yes. Consider probably writing a proper else in this case, because at some stage you will get quite easy. So careful about it. Now, one more flow control statement we need to cover in this lesson is switch. Switch statement is kind of very different from else. Firstly, it doesn't work with Boolean expressions. In fact, the switch works with a variable here, with an expression or value that has to be byte, short, int, char, string, or email. We cover emails and strings later, so don't worry about that. At the moment, we will actually see the example of switch with emails and stuff later. But for now, these are the possible types that you can use with emails. Notice Boolean isn't one, right? So it's not like anything else. So what it is that you evaluate in the switch? You essentially evaluate a target to which the code should jump. It's a bit like, not really, but sort of vaguely related to a similar idea. Cases are essentially targets where you go to. The switch derives which one of these targets you want to jump to. So cases can be labeled with something that is either byte, short, int, char, string, or email. In this particular case, it's char. So let's imagine I've got some product, and it could be new, special, discounted, expired, and maybe I need to calculate the price differently based on that statement. So I have all of these different cases, and I calculate them. How this output works? So when you get into the switch looks at the value of the expression here, the status in this particular case is n. So we'll jump to whichever case matches that. So case n. Say, for example, expression will be s, so we'll have jumped to case s, etc. So it jumps to whichever case matches the expression. And then it continues, execute in this case. And then it continues, execute in the next case. And so on.
Que no, señor.
Break. You don't have to put a break in. You may put a break in inside every case. That's entirely up to you. You may put a break in some cases, but in others.
¿Me vas a ayudar a hacer la cena?
And possibly go to the next case if this particular case didn't contain a statement. Then you continue to the next one until you encounter a break or until you get to the end of this. If you encounter a break, then you jump out of the switch. If you don't encounter a break, just change line by line. If the switch expression derives a value that matches no case whatsoever, then you may handle the situation by placing default case. Default case is triggered when the switch expression matches no case. Default is actually, yeah, but it's up to you. When the order of cases, and it's completely in terms of various variables before arithmetics, castings, and so on. The J shell is known as the read evaluate preview. So this really handy because you don't have to all these formalities. You just want to play with the code, see what's what, how it works. You can even break things and colors. Well, if you're writing a block of code in J shell, you still need to terminate statements inside the block with set colors. So you type no bonus inside the block, you have to put blocks statements. But outside of the block, if it's just like an individual line of code, I usually still do it because, that's a normal Java syntax. But, if you just want to try something, it's a great tool for learning. You can also do some kind of basic scripting with that, because you can save and open files with that. If you need help with change documents, just like question mark gets you the help message. And to exit, it's and slash in front of the J shell. Slash help slash. There you go. So playing with these two really useful to learn Java, to practice code without actually having to just study things. That's that for this particular lesson. So whole numbers, to floating points, number times, chart. We look at the operators we can apply to that, order of precedence, castings, promotions, some more advanced mathematics and finally, the tool that we will explore the exercise practical exercise in this lesson. Variables performed, various operations on that, and also some flow control and a trend.